All right, sections 4.1 and 4.2 are all about exponential functions, so I'm going to kind of lump them together into one thing. So we have here the definition of an exponential function. It's one of the form a times b raised to the x. So instead of having like x squared, where x is in the base, now x has moved into the role of the exponent, and it completely changes what's going on with these functions. All right, so this might be the function, let's say f of x equals 2 times 3 to the x, or maybe g of x equals -5 times 2/7 to the x. All right. In general, the b of the function, the 3 or the 2/7 in my examples, we call that the base of the function. And then the number a, whatever that is, we call the initial value. And we'll talk more about the initial value in a later video. Today, I want to focus on that base and what the different values of b would change about the graphs of these functions. So here we have a really simple exponential function, f of x equals 2 to the x, and I want to graph this one by plotting points. All right, so we're going to need our exponent rules to figure this stuff out. We're going to plug in x equals all the integers between -3 and +3. All right, so I'm going to plug in -3 into 2 to the x, so that's going to be 2 to the -3. And if you watched the exponent review, we did exactly this exponent. This means that that 2 cubed wants to be down in the denominator. So this is equal to 1/8. And that means I'm going to plot the point -3, 1/8. That's going to be really, really close to the x-axis. So -3, 1/8. Essentially almost sitting on the x-axis. I don't have enough resolution to get a really good approximation of where that is. All right, so let's keep going and see what we get. When we do -2, 2 to the -2 will give us 1/2 squared, or 1/4. So we'll go plot that point. 2, 1/4. I haven't even made it all the way up to a half yet. -1, 2 to the -1, 1/2 to the 1. There's my 1/2. All right, so slowly but surely these values are getting bigger left to right. Let's see if that keeps going. So then I'm going to plug in 2 to the x, 2 to the 0. Anything to the 0 is equal to 1. So I get the point 0, 1. Then I'm going to plug in 2 to the 1. That one's easy, 2. So I'm going to plot the point 1, 2. Next up, x equals 2. 2 squared is equal to 4. So I'm going to plot 2, 4. And last one, 2 to the 3rd is equal to 8. And we kind of get the idea that if I keep going, these y coordinates are going to get enormous, right? 2 to the 4th, 2 to the 5th, 2 to the 6th. I'm going to get up to 16 and 32 and 64. I'm like way off of the page now. All right, so but we get a good idea of what this looks like. The values were getting very small. As I went out to the left, they were getting teeny tiny and flattening out. But then as I go to the right, they're getting huge, almost growing like a polynomial. In fact, they're growing faster than a polynomial. All right, so I'm going to kind of fill this out. Here's my growth half. And to the left, this should remind you of rational functions with a horizontal asymptote. And it actually is a horizontal asymptote just over to the left. The x-axis is behaving like a horizontal asymptote. All right, so this is the graph of f of x equals 2 to the x. I want to do one more plotting points graph with you. All right, so this one's going to be a little bit harder with the exponents. We're going to graph 1/2 to the x. We're going to look at what the difference is if the base of the function is tiny, like a fraction. All right, so when I plug in -3, this will probably be the hardest one, 1/2 to the -3. All right, there's a couple of ways to think about this. I'm going to distribute that negative exponent over the fraction. All right, and then I have those two things with a negative exponent, which means they really want to be on the other side of the fraction. So the 2 to the -3 wants to come up top as 2 to the +3. The 1 to the -3 wants to move on to the bottom as 1 to the 3. So we just get 8 divided by 1. So we have the point -3, 8. All right, so before we had a teeny tiny y coordinate over here, and now we've got a pretty big one. All right, so let's keep doing this. This is going to look familiar after a while. So I've got 1/2 to the negative 2. I'm going to distribute 1 to the negative 2, 2 to the negative 2. They flop sides of the fraction, become 2 to the positive 2, 1 to the positive 2. That gives me 4 over 1. So I've got the point negative 2, comma 4. 1/2 to the negative 1. Distribute the negative 1. Swap sides of the fraction. 2 to the 1, 1 to the 1. 2 divided by 1 is 2. So I've got the point negative 1, comma 2. This will get easier now. I got 1/2 to the 0. This is always the easiest one. Anything to the 0 other than 0 is equal to 1. So I've got the point 0, comma 1. 1/2 to the first power is 1/2. I've got the point 1, comma half. 1/2 raised to the 2 power. Again, we're going to distribute exponents. So I've got 1 squared over 2 squared, so that's 1 over 4. Get that fraction. These numbers are looking really familiar. And then I've got 1/2 cubed, which is 1 cubed over 2 cubed, or 1 over 8. All right, so 3 comma even smaller, really close to the x-axis. And again, we get this same sort of thing just on opposite sides of the y-axis. So on the left-hand side this time, it's getting really, really big as it moves out. But over on the right, it's flattening out with that horizontal asymptote behavior. So let's fill that in. We've got the growth half, and then the horizontal asymptote behavior. All right, so there's the graph of 1/2 to the x.